In this video, we will talk about the limits at infinity. Given f of x is equal to 2x plus 3 all over x minus 4, let's find the horizontal asymptote and vertical asymptote. To find a vertical asymptote, we want to set the denominator to be equal to 0, because in a function, when the denominator goes to 0, that's where it's undefined. So to find the vertical asymptote, you set the denominator equal to 0. So at x equals to 4, that's where it's undefined. So x equals to 4, where this point is 4. To find the horizontal asymptote, we want to compare the x value as it approaches infinity and x value as it approaches negative infinity. We have 2 times the infinity plus 3 over infinity minus 4. When we are talking about infinity, the number is so big, plus 3 or minus 4 of a really big number does not matter. So we can ignore these two values, and what we're left is 2 times the infinity over infinity, so the rates between these two are going to be 2. If we're talking about negative infinity, the idea is the same. You have minus 2 infinity plus 3 over minus infinity minus 4. Again, a big number, when you're talking about a big number, the 3 and 4 does not matter. So we can kind of ignore that, and the ratio between the numerator and denominator is equal to 2 again. So at y is equal to 2, that's another asymptote. Since this is a rational function, we know they come in pairs. So when you plug in for x equals to 0, when x is equal to 0, the y value is negative 3 over 4. So you know it needs to pass through this point, so the graph of this function, which comes in pairs, will look somewhat similar to this and this. So let's talk about infinity one more time. As x approaches negative infinity, the f of x is approaching. As x approaches negative infinity, the y value is approaching, which it's getting closer and closer to 2. As x approaches positive infinity, f of x is approaching positive infinity. So we're going in this direction all the way. It's approaching 2 again. As x approaches 4 from the left side, f of x is equal to, 4 from the left side. So from the left side, it's approaching 4. The x is approaching 4. The y value is approaching negative infinity. Lastly, as x approaches 4 from the positive side, you can imagine that f of x is approaching 4 from the right side. So we're going in this direction. It's approaching positive infinity. I highly suggest pausing this video and try this problem on your own. Discuss the behavior of f of x is equal to 2 minus x over 1 plus x near its asymptotes, and hence deduce their equations. First, we need to draw this graph. So when the denominator goes to 0, that's where the function is undefined. So at x equals to negative 1, that's one asymptote. To find horizontal asymptote, you need to look at the behavior as x approaches infinity and as x approaches negative infinity. As x approaches infinity, you have 2 minus infinity over 1 plus infinity. 2 and 1 is too small compared to the infinity, so we can ignore, and we're left with negative infinity over positive infinity, so the rate between these two are negative 1. If you plug in negative infinity, you would get 2 plus infinity over 1 minus infinity. So then 2's and 1's are so small you can ignore those parts, and we're left with, once again, 1. So that's going to be your horizontal asymptote, so set that to be equal to y. So the graph of this is undefined when x is equal to -1 and y equals to -1. When you plug in x is equal to 0, when x is equal to 0, you pass through a point 2. So this time the graph will look like something like this, and they come in pairs, so something like this. So now let's look at the behavior near its asymptotes. As x approaches infinity, as x is approaching infinity, y is approaching -1. As x is approaching negative infinity, y again is approaching -1. As x is approaching -1 from the left side, so from the left side we're going to -1, the y value is approaching negative infinity. As x approaches -1 from the positive side, the y value is approaching positive infinity. Second part of the equation says, state the values of limit as x approaches negative infinity of f of x. As x approaches negative infinity, we have a y value approaching -1. As limit of x approaching positive infinity f of x is approaching -1 as well. Find, if possible, limit as x approaches negative infinity of 3 minus e to the negative x. When you graph this function, you will get the following, and let's talk about what happens as x approaches negative infinity. As x approaches negative infinity, the y value keeps on decreasing. So as x approaches negative infinity, it's going to negative infinity. Since it is not approaching a finite value, the limit does not exist. Limit does not exist as x approaches negative infinity. What happens as x approaches positive infinity? As x approaches positive infinity, the value of y is approaching 3. So for the second part of the question, it's equal to 3.